Hello everyone, welcome back to the channel. So our first experiment is to design and simulate all the logic gates with two inputs using VHDL. Okay, so I am assuming that you have installed the Xilinx IDE. If you did not install yet, so please find the Xilinx IDE on internet and download it and install it yourself. The installation method is so easy, so I am not going to show this here. Okay, so let's after you install the Xilinx ID, you need to open a project or you need to create a new project. So I am naming this project as experiment 1 all gates. Then you need to select the language. So I am selecting this as HDL. Then you need to click on next. After this you need to mention your CPLD or Xilinx board that you have in your lab. So we have XC9500 CPLDs and family, and we have XC95108 CPLD device in our lab. So I am selecting this and the package is PQ100 and the speed will be -10. Then you need to select the preferred language as VHDL and simulator as iSIM. Then click on next and then click on finish. Here you will see on the left hand side you will find a hierarchy. Under the hierarchy or tree you will find a name XC95108. So you need to right click on that and you need to select new source. Here you need to select VHDL module and you need to name the file. So I am naming this file as all gates exp1. Okay, then you need to click on next. Make sure that you have selected VHDL module. Here you need to mention your input and output as per your requirement. So I am performing all the logic gates, right? So we need to take two pins as input. So let's see, A comma B is inputs and output will be out end, out or, out not, out NAND, out NOR, out XOR, out XNOR. So we have mentioned all the output as per our gates, right? So we have AND gate, OR gate, NOT gate, NAND gate, NOR gate, XOR gate, XNOR gate in our outputs. Then we need to select the direction as out. Okay. Then you need to click on next. Here you can see we have A and B as input pin and all the gates as output pins, right? Then you need to click on finish. Here you will see Xilinx ID will assign the libraries automatically, and you will find two things, that is your entity and second one is architecture. Now you need to write your code under the begin section. Here you need to mention all the code. So let's writing out end, and we will assign this out end as A and B, right? Same, we need to assign out or as A or B. Then we need to assign out not as not of A. Then we need to assign out NAND as A NAND B. Then out NOR as A NOR B. Then out XOR and A XOR B. Then out XNOR as XNOR A XNOR B. Okay, so we have assigned all our outputs as per our requirement gates, right? So this is enough for the code. Then we need to run this code. So on the left hand side you will find the run button. So you need to click this run button, right? Then you need to save this code, and it will compile your code before it will run, right? So you need to run your code before you move towards the implement design. It will take some time. Now you can see we have successfully run our file. Now you need to click on view RTL schematic. Okay, then you need to select start with a schematic of the top level block, then press on OK. Here you can find your RTL schematic diagram. Okay, so let me zoom out for you. Okay, now you can see you need to paste this diagram on your lab record. So you need to save this from here, print preview, and you can print this out. Okay, then yeah, we need to run our test bench for our simulation. So for to run your test bench, make sure that you have click on the again here, and you need to select new source, and then here you need to select VHDL test bench. After you selected the VHDL test bench, you need to name the test bench. So I am naming this as exp1 all get test, right? Then I am pressing on the next button. Then you need to select your VHDL code, that is all gets experiment 1, that I have already written down before. Okay, so press on next, then click on finish. After you clicked on finish, you have a new file generated automatically, that is test bench file. Okay, so this is your test bench file. Okay, so here you need to mention your input for your outputs, right? So you need to give a signal to your inputs individually. So we have two inputs, right? A and B, and every inputs will be 0 or 1. So we need to mention 0 0, 0 1, 1 0, and 1 1 respectively. So let's assign this. A assigned as 0 first. Okay, then B assigned as 0. Okay, then we are giving a clock pulse of period into 10. Okay, then we will assigning A as 0 and B as 1. Okay, then we will again giving the clock to wait the input. Then we will assigning the A as 1 and B as 0. And then we are assigning A as 1 and B as 1. Okay, so we have 0 0 0 1 1 0 and 1 1. Okay, now let's save this, and then you need to click on the all gates experiment behavioral, and make sure that you have clicked check the simulation button. Then you need to click on the behavioral test bench. Then here you will find the iSIM simulator. You need to click on the behavioral check syntaxes. Okay, so we have some error on that. Let's find out what is the error. Okay, so it is saying that in period we did not choose the less than operator. Okay, so we need to remove this as uh, let's remove this here, from here also, from here. Here I am copying this, copy and pasting this here. Okay, so we now have no error, I think. Okay, we have two more errors, 92 and 94, right? We need to remove these clock process definitions, right? So let's remove this. Okay, now save this again and run this again. Okay, now your code has been compiled successfully. Now let's run the simulated behavioral model. Okay, when you run this, you have a new window pop up on your screen, and that is the iSIM simulator. So in the iSIM simulator, we will get our simulation output, that is in the form of all the logic gates that we have mentioned in our code. Okay, so let's see this. Here you can see that, let me minimize for you. Okay, so here you can see that we have A and B in our input field. Okay, and in our output field we have out and, out or, out not, out NAND, out NOR, out XOR, out XOR. Okay, so in the when we move our cursor in the first 0 to 100 nanosecond, you can see that we have input as 0 and 0, and we have output as per our gates. Then if we move our cursor in from 100 to 200 nanosecond, we have is A as 0 and B as 1. Then respectively we have A as 1, B as 0, and at last we have A as 1 and B as 1. Okay, so this is your output. You need to save this by clicking on the file button and print preview button. Here you can see your file as output layout. This is your simulation output. You need to save this and print out. Make sure that you have get your printout done, and just attach this printout on your lab record. That's it for your lab experiment. So this is your first experiment, that is that we have covered all the logic gates. In the next experiment we will cover the 2 to 4 decoder. Okay, so thank you for watching this video.